Geology in a Jiffy! What's in the bag? It's
Fractional distillation of crude oil. Fractional distillation is a separation technique used to separate a mixture into its component parts, namely fractions. If we take a cold liquid and heat it, it will increase in temperature until it gets so hot that the liquid turns to a gas. A liquid changes to a gas by the process of evaporation, which we know can happen at a specific boiling point for a liquid. From our Geology in a Jiffy video about fossil fuels, we know that crude oil is a very viscous, dark-coloured, smelly and quite dangerous chemical, but it is probably the most important chemical we have because from it we get these important chemicals and products. But how is it that this disgusting chemical can be so useful? The answer is by fractional distillation, which happens in a fractionating tower, which can be found in oil refineries. If we study a fractionating tower, we see this in cross-section. We start with cold liquid crude oil, the black sticky mess, which, if we study more closely, is made up of a mixture of different length hydrocarbon molecules. Firstly, the cold liquid crude oil is pumped in, then strongly heated, so making the base of the fractionating tower hotter. This cooling as one moves up the tower. Knowing that liquids boil and evaporate at specific boiling points, we can see that as the hot gases rise upwards inside the tower, we see that the boiling points decrease upwards too. Knowing that when a gas cools, it condenses back to a liquid at a specific boiling point, we can therefore use this physical property to identify the fractions that are poured off as the gases cool, which from crude oil, starting at the base with the highest boiling point are bitumen, heavy fuel oil, lubricating oil, diesel, kerosene, petrol, known as gasoline, and finally, refinery gases. If we were to look at each of these fractions, we see that the fractions with higher boiling points at the base of the tower are much darker in colour, the colours of the fractions becoming much lighter as one moves up the tower. If we study the flammability of the fractions, that is the ease at which they ignite, we find that the fractions with higher boiling points at the base of the tower are much more difficult to ignite, and as one moves up the tower, they become much easier to ignite. If we study the ease of flow of the fractions, this known as viscosity, we find that the fractions with higher boiling points at the base of the tower are very viscous, or thick and gloopy, whereas the fractions at the top of the tower with a lower boiling point are very runny, or much less viscous. So these fractions, fractionally distilled from the original dark-coloured gloopy crude oil, this mixture composed of different length hydrocarbon molecules, when we study the resulting fractions, we find that the further up the tower we move, the shorter the length of the hydrocarbon molecules. In summary, the process of fractional distillation of crude oil is that we heat the crude oil, which is a mixture of hydrocarbon compounds. This causes the crude oil to evaporate at different temperatures, which separates the fractions. Then the fractions condense as they cool. The fractions are then poured off to be processed. We start with crude oil, a mixture of different length hydrocarbon molecules, which are pumped into a fractionating tower and heated. The different molecules then boil at different temperatures, the boiling points related to the length of the hydrocarbon chains, allowing us to extract these extremely important chemicals for using and processing.
That's amazing!
Longer length hydrocarbons have a higher boiling point. Shorter length hydrocarbons have a lower boiling point. The fractional distillation of crude oil.
Please subscribe to my channel. Bye!